Give me 5 minutes. Actually, I'm need to take care of something. I will start 5 minutes.
Good morning, sir.
Morning, Ajit. स्टार्ट कर दे ठीक है 10 पेज लगे बस Okay, good morning, guys.
Okay, good morning, guys. Okay, good morning, guys. Okay, good morning, guys. Okay, good morning, guys.
I hope you guys can hear me.
Yes,
Yes, sir.
Wonderful. So let's look another example where we need to understand how lambda and mu's needs to be understood before proceeding to solve the problem. So carry here is characters. Read this question carefully and try to solve on your own completely so that you have some confidence how to solve such problem. Are you guys able to proceed? Okay, what is lambda equals to?
4, sir. 4 messages per second.
I'm sorry.
4, sir.
So lambda equals to 4 what?
4 message per second.
Sir, 704 characters per second.
What is that again?
704 characters per second.
704 or 0.704?
Sir, it's 704.
704 character per second.
Yes, sir.
Okay. Anything else? So based on that, Nicholas, how much L you are getting?
Sir, 0.L.
Was that? So first thing you need to understand what kind of queue is being generated. Is it because of characters or because of messages? The request that is coming that I have to send this much. Think of it as I'm not sure if you guys remember the TAR telegraph. So the requests are coming for different character per second, messages per second, and then you have to figure out how you generate the queue of the different masses that needs to be sent to the transmission. Does that make sense? Okay, so what has been given? What is first we need to understand what kind of queue it is. What kind of queue it is? For obvious reason, because there is only one server which is processing these messages. So we first need to understand what is expectation of the system. So average message length divided by line speed. This should give you the expected value. So average message length is 1676 character per message divided by 800 character per second. So what you will get is 0.22 second per message. Does this make sense? So what is E of S I have calculated here? We do not discuss how do I be able to proceed, guys. Whether it makes sense or it does not make sense. Akash, is it clear?
Sir, what is line speed, sir? Like transmission rate?
It is the transmission rate at which it can, send the, so suppose in 1 second, I can send 800 characters. Think of it as a printer. So in a second, it can print 800 characters. Does that make sense?
Yes, sir.
So here is the thing. Messages are coming to a transmission center that needs to be sent to wherever it is being sent. Think of it as a fax itself. So each message on an average is of 176 characters. Okay. And in 1 second, I can maximum send 800 characters. So first I need to understand what is the expected service time. So what we have calculated is expected service time. Average message length divided by the line speed. That gave me, I can send one message in 0.22 seconds. Does that make sense?
Yes,
So
sir.
what is mu equals to? Is this part clear to you guys or not? Or should I start asking one by one? If it is not clear, discuss with me, so that it becomes, what exactly we are trying to calculate. What we need is mu and lambda.
Mu equal to 1 by 0.22.
1 by 0.22, that is definitely 1 by ES, it will be expected service time. But what I'm trying to highlight this fact that many a times mu and lambdas will be not given directly to you, right? So you have to understand how to calculate those numbers. So this will be simply how much? 4.55 messages per second. That is your service rate. What is your lambda? Deepak? Deepak Kumar?
So,
Yes. What is your lambda?
so lambda will be this 704 characters per second.
When I'm talking about messages per second here, why you are going into characters again?
4 messages per second.
4 messages per second, because simply it is 240 messages per minute. We have already talked about. So you have to just convert into seconds. So 4 messages per second. So now you have your mu and lambda, and then you can calculate all these numbers. So still for you to calculate, I want you to give me these numbers.
I have one doubt.
Yes.
In the question you have written that arrive in a random pattern. If it is a random pattern, then why we are considering it's a Markovian?
So what is random pattern probability distribution wise? What probability distribution we assume when it is a random pattern?
See, if it is a
Generally,
random process,
such distribution we use Poisson distribution or not?
mm, if we calculate the number of arrivals, then it is a Poisson. But so only based on random can we take a decision that which distribution it will be.
Okay, tell me, Abhijit, which distribution you will use?
Even I can
Because
use
given that it is saying random pattern with an average rate, which distribution you would like to use? I'm not saying random variable, I'm saying a random pattern. So generally, if you remember when we learned Poisson distribution, in fact, most of the telephone calls are coming in a random pattern, and we consider it as a rare event in each time, that every event that is happening is actually a Poisson distribution.
Okay, sir.
Do we have any other distribution you think will fit this?
No, logically process wise, no, but yeah, my point is that if nothing is mentioned directly, can we
Okay,
assume that
so
yeah,
let's make it easier for you. We are discussing MM1 and this is the question you have got. Does that help?
then fine.
Good, great. Okay, so once we
Excuse me,
know
sir.
mu and lambda, then
Excuse
it
me,
is just plugging into your
Excuse me.
L, LQ,
Excuse me,
W,
sir.
and WQ. You will get I expect you to do all this calculation because this is where many students make mistake. They think they already have got the lambda and mu and life ends there, but it is expected that you get all these numbers. But before that, I
Excuse me, sir.
forget to ask you, whenever you are proceeding with MMU, just check lambda by mu is less than 1 or not. If it is not, we will not proceed. Okay?
Excuse me, sir.
Yes.
Sir, for calculating mu, sir, what I have done is that I have changed the 800 characters into number of messages per second, like 800 divided by 176 into 60.
Okay.
So that way also I'm
Just hold
getting
on.
like,
Let me put it in there. So expected service time. What is the formula you are using?
sir, I have changed the 800 characters into number of messages, like it is given in the transmission.
800 characters per second into number of messages. So how
Sir,
much you are getting?
800 divided by 176 is the number of
800 by
messages
176
into
messages per
60.
second.
Sir, into 60 for converting it to
Okay,
seconds.
see, as I said, you can proceed with any kind of unit. So how much you are getting mu as?
Sir, mu I'm getting 272.72
What is the unit?
messages per second.
No, so
No, sir.
60 multiplication is not needed. I
Not
think,
needed. Yes.
Why
yeah,
you are doing multiplication in that manner? Because it is already in seconds. So why 60?
Sir, because it is given in minutes, sir. If you can show the question, sir.
Which one is given in the minute? It is the arrival rate, not expectation, your service rate.
Sir, I'm getting the same answer, like 240 divided by 272.72. I'm getting
No,
0.8.
this is, I'm not sure. I have to see, look at your answers, notebook. Is my screen not moving?
No, sir.
So it says the random pattern at an average rate of 240 messages per minute. That is your lambda, right?
Yes, sir.
Now the line has a transmission rate of 800 character per second and average length of the message is 176 character. So from here, if you are trying to find your mu, how much you are getting?
Sir, 272.72 messages per minute.
272.72 messages
Per minute.
per minute. So ठीक तो ऐसे same ना?
Yes, sir. So I have divided like for.
I'm saying that if you maintain the unit for both of them, it is fine. 272.72 messages per minute. Then
Yes, sir.
per second, how much it would be? Divided by 60.
Yes, sir.
So it will come out to be same.
Same.
272.72 you are getting in minute divided by 60. 64 ja 240 32 point
4.545.
something like that only, right?
Yes, sir.
4.5.
As long as you are maintaining the making sure that mu's and lambdas are in same unit, nothing to worry, you will get the same results.
Yes, sir. L and LQ I'm getting 7.334 and LQ is 6.45.
Okay, wonderful.
Sir, I have one question, sir.
Yes, please.
Sir, why are we finding the expected service time, or sorry, the rate?
I mean, you can do it otherwise also. You take the 800 character per second on the numerator and divide it by 176 character per message. You will get the same thing.
Yes, sir.
So expected, see, if I'm saying it is an exponentially distributed, it will have a mean or not.
Yes, sir.
That mean is mu. That mean is actually 1 by mu.
One way.
Right. So mu is simply your rate.
Correct, sir.
Does that make sense?
Yes, sir. Yes.
Okay. Now let me. So I will tell you the economic model little later. but this question is more or less related to economic model of queuing economic model, but we can work with it without any you know understanding of economic models. I will try to explain with this example. So any questions, guys? So the only reason I have given you this question is to understand that mu and lambdas needs to be calculated, and many a times it is not directly given to you. You have to understand from the question that what your mu and lambda is. Once you have understood, try to bring them in the same unit, check lambda by mu less than 1 and proceed with the LQ, WQ. So assume on an average 96 patients in 24-hour a day. 24-hour day. I mean, just confirming that they are only 24 hours in a day. Require the service of an emergency clinic. Also, on an average, a patient requires 10 minutes of active attention. Assume that facility can handle only one emergency at a time. Suppose it costs rupees 100. So I'm bringing the economic part of the queues. Treated to obtain an average servicing time of 10 patients. So in this question, we are talking about emergency room of a hospital. Read the question completely and then try to solve it. If you have any question, any clarification regarding the question, please feel free to ask me before you start solving it.
Sir, what is the meaning of the last line, sir? Like,
so it is saying how much would have to be budgeted by the clinic to decrease the average size of the queue 1 and 1/3. So that is 1/1/3 to half. What else is not clear? So what is directly given to you, Akash?
sir, the arrival rate.
From this line, what is given to you directly? Something is directly given to you. Average size of the queue is given to you already, what is existing. And then what you want it to be, that is also given to you. Does that make sense?
Yes, sir.
So this is existing. Now, to bring it down to this much, how much more you have to budget? Understood?
Yes, sir.
Good. बोलिए दादा।
Hello, sir.
Yes, Thomas, you guys.
Sir, will mu, sir, how will we find mu? Sir, service time is given 10 minutes. So
Yeah.
will it be one patient per 10 minutes?
So 10 minutes means one patient requires 10 minutes of active attention.
So, sir, mu should be one patient per 10 minutes.
So what should be mu be?
Sir, 144 patients per day.
Yes, sir.
You don't really need to make it bigger. You can work with 1 by 10 patients per minute, right?
Yes,
Try
sir.
to keep,
So because lambda is 4 patients per day.
much?
Sorry, sir, 96. It's 96
Okay,
patients.
so I understand. Many times it get confusing. Just look at one of the, either you can convert into minutes or you can convert into a day.
Right, sir, right.
Okay, but
Yes, sir,
generally
yes.
I mean, it is not mandatory, but generally what we do, we prefer to take the smallest unit when we work with lambda and mu. So anyway, your numbers are right, but if I just look at lambda and mu, lambda is 96% by 24 into 60, that is 1 by 15 patients per minute.
Per minute, yes, sir.
And mu is 1 by, so how
10
it helps?
patients.
It at least help me in reducing one number. So 1 by 10 patient per minute. Good so far. Let's just
Yes,
check
sir,
if
understood.
rho is less than 1 or not. So 15 by 10, 2 by 3. Okay. From which line you know that it is an MM1?
Sir, it is written that it can handle only one
Only
emergency
one
at a time.
emergency at a time. From this line, you know
Yes,
it
sir.
is. So you can use LQ equals to rho square by 1 minus rho. But anyway, this number has already been given to you. What we are interested in, we want to bring this 3 into 1 plus 1, 4 by 3 to half a patient per minute. This is my expectation is that my average Q size should reduce from 4 by 3 to 1 by 2. So what is needed to be changed? If I want
Sir,
to reduce
service
my,
time, mu.
yes,
Mu.
please go ahead.
Sir, mu should change, right?
Okay, so we want to change our mu. So we want LQ should reduce to half. So we'll write lambda by mu nu whole square by 1 minus lambda by mu nu. And this is equals to half. So give me, lambda is not changing, arrival rate is as it is, only change we want to do in the service rate. Tell me how much you will get as mu nu. What is the value of lambda? अरे इतना टाइम क्या लगा रहे हो छोटा सा कैलकुलेशन है
Sir, new row is coming 1 by 2.
Rho is coming 1 by 2. So what is mu?
2 by 15.
2 by
15.
2 by 15 patients per minute, which means 1 by mu or expected service time is 7.5 minutes. Good so far? So what is the reduction? So now read from this part. Currently, your serving. Anyway, I will not say. Just read this part and tell me what should be the budget. If I want to achieve this mu new. So earlier my mu was 10 patients per minute. I want to increase it to 2 by 15 patients per minute.
Sir, 125 rupees per patient.
Not per patients. Yeah, per patient, right? It is per patient, right? So how did you get that?
Sir, we saved 2.5 minutes. So every minute cost 10 rupees.
Very good. So 10 minus 7.5. If my service rate increases, I'm saving 2.5 minutes because earlier we will spending 10 minutes. Okay. Now we are sorting that emergency in 7.5 minutes. So we are left with 2.5, and it is already said that each minute decrease in this average time would cost rupees 10 per patient. So already 10 into 10, 100 we had, and this increase 2.5 into 10 is 25. So 125 is the budget we need to allocate for per patient. Does that make sense? Any questions? Any questions? So we need to, let me highlight this part, that each minute decrease in this average time would cost rupees 10 per patient treated. Already 100 per, I'm sorry, my bad, 10 into 10. So already it says that suppose it costs rupees 100 per patient treated to obtain an average service time of 10 patients. So 100 I'm already spending. There is a further decrease of 2.5 minutes to 2.5 into 10. I have to add this. So 125 rupees I have to spend on per patient to achieve this service. Right. Is this clear?
Yes.
Sir, what is I have one doubt. Hello.
Yes, please go ahead. Tell me.
Sir, can you show me the question?
Yeah.
Sir, what is this line saying like average servicing time of 10 patients? I understood that it was taking like 100 rupees per patient, but treated to obtain an average servicing time of 10 patients.
So suppose it costs rupees 100 per patient, treated to obtain an average service time of rupees 10 patients. So suppose when I'm treating this patient, okay, so I have to budget 100 rupees per patient. That could be the medical staff, your doctor or nurse or whatever in per patient you are serving, or the support cost like ventilators and all that installed here. So that cost you rupees 100 per patient. Now with this rupees 100 per patient, you can achieve a service time of 10 patients in a one patient in 10 minutes. So since I'm able to decrease 2.5 minutes from 10 minus 2.5 minutes, 7.5, 2.5 minutes, that would be another into 10. So I have to now allocate 125. So that could be with a medical, doctor. There is an intern with also associated with that, or more nurses have been, allotted to that emergency station. Does that make sense?
Yes, sir.
Any other question? You can also think from perspective now that suppose there are enough facilities and I'm spending allocating that every patient I'm treating, I will spend 100 rupees. In that case, I can get this average service time of 10 patients, which is given to us. But if I want to increase, I want to treat more patients, then I have to reduce my service time. For more to reduce service time, I need to hire more staffs. Hiring more staffs cost me rupees 10 per patient treated. So this is another way to look at it. Fair enough? Okay, so we'll take a quick break and we'll again meet at 11, and then I will tell you something about bulking and drainaging. Queuing system where people either refuse to enter or leave the system after entering it. So how do we model such system? It is mostly like lost sales you can think of. So we'll model it after the break. Okay, let's take a quick break and start. Okay, I hope you guys are back. So let's look at balking and reneging. So we say customers have balk means refuse to enter the system. I was giving this example other day that suppose you went to ATM machine and you saw there are already some n number of customers or n number of people who are. You guys can hear me, right?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
So so suppose you want to withdraw some money, you went to the ATM machine and you saw there are already n customers in the system. So you decided not to enter the system. So although it looks like you came, you saw the system that it has n customers and decided to move, but from queuing system, it has affected something. What exactly it has affected? If you think from a BD process, queuing system, it has affected something. What exactly it has affected? So ideally, a customer arrival has happened, but since you have not entered the system, did it affect your arrival rate or not? Are you following? What it has affected?
Arrival rate.
It has affected your arrival process. Arrival actually happened, but did not get service. So that is your balking, which affects the arrival rate. Then there is a reneging. That means, so suppose for some reason you entered the system, okay, and after some times you got very impatient, you become impatient and you left the system. So left without being served. So what it affects? So suppose if you look at from the queuing system perspective, although suppose there are 10 people in the queue and based on that you are calculating your values, but suppose the mu, that is service rate, is 2 per hour. The moment you leave the system, it assumes that you have been served. So it affects your the service rate. Are you following how this is affecting your service rate and arrival rate?
Yes, sir.
So again, I will repeat ATM machine. The first part is arrival process. That is, you arrived, but you saw n people, and based on some probability, either you will join the system or not join the system. That affects the arrival rate of the queuing system. When I talk about reneging, you entered the system, but after sometimes you become impatient and decided to leave the queue or decided to leave the system. But system as a whole thinks that you have been served, although you have not been served. So it is reneging. So based on this, I'm gonna give you an example. So example, I think it is fourth. Potential customers arrive according to, yes. Any question? To Poisson process with mean rate 4 per hour. So these are different languages that you will see in the question. So instead of saying rate, it is calling it mean rate. It is the same thing. Now, potential customers who finds n customers already there will bulk with following probabilities. So probability bulk n already there. 0, 0.5, 0.75 and 1. So if there are 0 customer, the person will not bulk. If there is 1 customer, person will bulk with a probability 0.5. Person, if there are 2 customer, it will bulk with probability 0.75. And if there are 3 customers already in the system, person will definitely bulk. Service time is exponentially distributed with mean of 1 hour. Okay. Now let's talk about the reneging part. The customer already in service never renews. But the customer in the queue may renews now from here onwards, read it carefully. The remaining time that the customer at the front of the queue is willing to wait in the queue before reneging has an exponential distribution with mean of 1 hour. For customer in the second position, the queue the time that C is willing to wait in the position before reneging has an exponential distribution with mean of half hour. Okay, So read the question carefully. Ask if you have any need any clarification, and think how you can solve this problem. Is the question clear, guys? Okay, so what is the maximum number of people in this system? Or how many states are possible for this system?
Sir, maximum 3 people.
Maximum there can be 3 people, because the moment there are more than 3 people with probability 1, arriving customer will bulk, right? Agree? See, the moment there are more than 3 people in the system, arriving customer will bulk with probability 1, we already know. So let's try to first draw the rate diagram. We cannot use the queuing theory formula directly here. You understand? Because lambdas and mu, I mean, you can, but first we need to understand what are my lambdas and mu's. So how many? 0, 1, 2, and 3 customers. Now, most important part is to understand what are my lambdas and mu's. So rate diagram becomes necessary for such system, and then we can do whatever we want to do. So 0 to 1, at what rate customers are arriving? What is the arrival rate?
4 per hour.
4 per hour. So lambda 0. Okay. Now 1 to 2. What rate it is becoming 1 person in the system to 2 person in the system? Yes, guys. So here this probability plays a role.
2 per hour.
How did you get that 2?
Because probability that if there is already 1 person in the queue,
Yeah.
then 0.5 probability that he will return back. So the arrival rate will be 0.5 into 4.
So just I will not write 0.5 directly, but let me write it as So there is a 50% chance that person will leave the system.
Correct.
So 50% chance is person will enter the system. So that is 1 minus that 0.5. Now from 2 to 3, what is the arrival rate? Similarly, 4 into 1 minus 0.75. Because there is a 0.75 probability that he will not join the system. So probability of joining the system is 0.25. Is this clear, guys?
Yes, sir.
So how your arrival rate is being affected because of the bulking process? Is this part clear?
Yes, sir.
Okay. Now let's look at the departure rate. So 1 to 0, at what rate it will leave the system? So 1 person in the system being served. So it is simply equals to your service time. Because if there is only 1 person, that means he is being served. If there is only 1 person in the system, that means he is being served, and problem clearly states the customer already in service never reneges. So there is no point that he will leave the system. Now 2 to 1. So think of it as this is my server. Here is the person being served, and there are 2 people waiting in the queue. This is at the first position and he is at the second position. So person in front of the queue, that means the person who is at the front of the queue will renege at not renege directly, at what how much time he will wait before reneging?
1 hour.
And what is the service rate of the system? So I'm writing mu2 equals to 2. Tell me whether it is correct or not.
Correct, sir. 2 hours. Well, because service time is 1 hour and then he is ready to wait for 1 hour.
So ideally system believes that 2 people have left the system in an hour instead of 1. 1 because of it being served by the server, 1 because of the person who will renege with exponential distribution of mean of 1 hour. Does that make sense, guys? All of you. Abhijit, is it fine? Am I disconnected?
No, sir.
No, sir.
No, sir, you are there, but I'm still thinking.
Okay. Think if you're still not clear, then I will discuss. First, I want you to think first if it is. So now coming to 3 people in the system, that means he is in the second position in the queue. He may or may not renege after waiting for another 1 hour. So what your mu3 should be equals to? This one is interesting actually, mu3. But follows the same logic.
Sir. Sir, mu2 should be, sir, it is from state 2 to state 1. That means a person is
Yes, go ahead.
It will be 4.
Mu3.
Yes.
Okay, that is correct. But let's sort out Kishan's. So why mute? Kishan, you had this doubt, na? Mu2 should not be equals to 2.
Yes, sir.
Yeah, tell me why do you think it should not be equals to 2?
Sir, because he is willing to wait for 1 hour.
Okay.
So I'll think once more and ask you again if I have a doubt.
Okay. So for mu3, I'm writing 1 plus 1 plus 1 by 2. No, 1 by 1 by 2. So keep in mind, every one I'm writing, it is actually 1 by 1. So 1 by 1 by 2. So mu3 equals to 4R. So look at this rate diagram. If you have understood lambdas and mu's, you already know how to construct balance equation and solve it. So that is not a concern for me. But understanding how arrival and departure process is being affected because of bulking and renaging, that is more important to understand. So any question on the arrival rate side? It is clear? Service time, I understand it sometimes becomes. So person who is being served, that means only one person in the system, he will never renege. So there is no point of considering renaging here. What we have to understand that it will be simply the service time that is required to serve that customer. Now, when I come to mu2, it is actually 1 plus 1 by 1. In fact, 1 by 1. Here also 1 by 1, because I have given you the mean, not the mu's and lambdas, mu's. So now the person who is waiting here on the second position, and that time person is being served also, right? Suppose, I mean, a situation that both of them started his service time and he started waiting at this position at, let's say, 10 a.m. Okay, at 11 a.m. his service will complete. He also wait for 1 hour and then he reneges. So when system looks at this, what it realizes, it has not served just this customer, but he has served two customers. Does that make sense?
Yes, sir.
Yes, sir.
Similarly, when we are talking about mu3, there are 1, 2, 3, 3 people. Again, I will take 10 a.m. example. At 11 a.m., this guy will be completely served and he will leave the system. In the meanwhile, as 1 hour, 10 to 11, there are chances that this guy will also leave. And there is 1 by 2 hour he will wait and he will also leave. So within this 1 hour, this may happens that it is not just 1, but 1 because of this, 1 because of this, and because he will wait for half hour. So after half hour, another guy came and joined the queue and he also waited for half hour and left. So total 4 person has left the system in 1 hour, but only one being served. Does that make sense? So 1 plus 1 plus 1 by 1 by 2.
Sir, I have one doubt.
Yes, follow.
Sir, here 0, 1, 2, 3 represent number of people in the systems. Yes, 0, 1, 2, 3. What are you writing there?
0, 1, 2, 3 is number of people in the system, right?
Sir, then after 3, 4 people will leave and system will be empty. And why we are
See.
pointing arrow towards to?
When we talk about birth and death process, I have talked to you about the distribution thing. It is not that for your ease of convenience, I'm telling you all of them has left. But mean 1 hour does not mean he will take 1 hour. Mean 1 hour means he may leave in 45 minutes. He may leave in 30 minutes, right?
Okay.
So what is mu? Mu is number of people per hour you are serving.
Yes.
Right? So it says that in 1 hour, I'm serving one person. But at position number 1 and 2 in the system, they also have an exponential distribution of waiting time, how much he are willing to wait and up before that. When I say that his waiting time is 1 hour, that is not necessarily 1 hour it will take. He may get impatient after 10 minutes and leave, right?
Yes, sir.
So it is a distribution thing. It is not that 1 hour it will take, but the system as a whole will see that in 1 hour I have served 4 customers. It could be possible.
Yes, sir.
Just
Yes.
practical example. This 10 a.m. it started and there were already 2 people in the system. So 10 or 20 his service completed, but his waiting he is willing to wait for 1 hour does not mean he is always waiting 1 hour. He may leave at 10:02 itself. He may leave at 10:05 itself. So we are talking about on an average. We are talking about the average time it waits. So based on that, we say that system is behaving in the steady state. Is this clear?
Yes,
Sir,
sir.
the units of mu will be 4, like mu3, 4 hours per person. Like it is taking 4 hours, or it will be 4 person per.
सर आकाश, अब तुम बताओ तुम्हारा म्यू का यूनिट क्या होगा? सर्विस टाइम का तुम्हारा यूनिट क्या होता है? जस्ट टेल मी व्हाट इज द यूनिट ऑफ सर्विस टाइम? Go ahead, give it a try, don't worry.
Sir, like per hour.
It is always in hour, not even per hour. Per hour is rate. Mean is 1 hour. Means one person can be served in 1 hour, right?
Sir.
Whenever you take the reciprocal of it, what it will become? Person per hour. Does that make sense?
Yes, sir.
So always service time, that as the name says, it is time. It will have a mean for whatever number of person can be served. So whenever you talk about rate, it will be person per hour or customer per hour, whatever you want to call it, messages per hour. So that is your service rate. Clear?
Yes, sir.
So now you have constructed the rate diagram. Either you can, use the formula directly, or you can write your own balance equation and solve it. You should get your value of P0, P1, P2, and P3. Go ahead and find this P0, P1, P2, P3. Then once you have found that, the next question I'm going to ask, find the expected fraction of arriving customers who are lost due to bulking. So in supply chain, you have read this concept, lost sales. So these kind of analysis becomes important. How many people I have left lost because of bulking, and you may start considering, how I can improve on my service so that bulking reduces. But anyway, try to find P0, P1, P2, P3, and then try to find how many people you have lost because not how many people you are expected to find expected fraction of arriving customers who are lost due to bulking. Go ahead, give it a try. How much did you get for P0, P1, P2, P3, guys? ये बहुत simple है. So, what is the balance equation for P1? If not balance equation, you already know. Lambda 0 by mu1 P0. Always try to describe all P1, P2 in terms of P0 and then add it up using summation Pn. So this you already know because you have already proved this. So this will be 4P0. This is also 4P0. P0, P1, P2, and P3 will be again lambda 1, lambda 2, lambda 1, lambda 0, P0 by mu 2, mu 3, mu 2, mu 1. This will be P0. If you add these up, P0 plus 4P0 plus 4P0 plus P0 equals to 1. That gives you P0 equals to. Anyone got it? How much it is? Yes, straightforward. Add them up. 10, 1 by 10. This gives you P1 equals to P2 equals to 2 by 5, P3 equals to 1 by 10. Just check if you have got same numbers. You guys with me?
Yes, sir. Same
Got
answer.
these numbers?
Yes, sir.
So always keep in mind, this is what you have to use to write the balance equation directly. You can always write it as we have written when we are trying to prove it. But you can always write it in this manner and then add all them up equals to 1. That will give you a P0. Now the question is find the expected fraction of arriving customers who are lost due to bulking. How do we go about it? So when there are 0 customers in the system, have we lost anything because of bulking?
No, sir.
If there is 1 customer in the system, have we lost anyone because of bulking?
No, sir.
We did.
Okay, after waiting on.
I'm talking about bulking, not reneging. look at this question. Find the expected fraction of arriving customer who are lost due to balking. And I'm writing, this is that value. Let me call it expected fraction, expected balking fraction. See if it is correct. Expected fraction of arriving potential customer who were lost due to balking. So first thing is probability that there is one customer in the system into the probability that arriving customer will bulk. Does that make sense? This expression, this quantity, probability that there is one customer in the system into probability that arriving customer will bulk. Does that make sense? Similarly, probability that there are two customers in the system, probability that arriving customer will bulk, and similarly P31, you will get the number. Any questions? Finally, can you give me the at least the expression for L and LQ? What is L? See, we cannot use the MM1 formula directly here. Keep that in mind. So if we do not, we cannot use, how can we calculate L in terms of birth death process? What is L in terms of N and PN?
Summation of
Yes, sir.
n pn n from 0 to 3.
Right? So in this case, we already know 0 will be lost. So 1 into P1 plus 2 into P2 plus 3 into P3. Is this correct? Similarly, N minus S, in this case, there is only one circuit, so Pn. So 1 into P1 plus 2 into P2. You can calculate these numbers. So this is how we can model a system with bulking and draining. Next, I have MMS queues, but let's start next on Thursday. Any questions?
No, sir, LQ should be 1 P2 2 P3.
Is it? Just let me check. So N equals to S2, 3 here now, N minus 1 Pn. So 1 minus 1, 0 gone. 2 minus 1,
1 P2.
1 P2. This is 2 minus 1. Yeah, 1 P2 into 3 minus
Plus
1
2.
P3. Yeah. Is it the case, guys? So 1 P2 into 2 P3 is your, because P0 and P1 will be lost because of multiplying it with the zeros. Thank you, Abhijit. So next class, we will look at the MMS queues. Most of the time it is difficult to, solve MMS queues by hand, but we'll look at the formulas and simple examples which can be solved by hand. And we'll wrap up then queuing theory. And next week, we'll start dynamic programming. We'll have good 4 hours. I cannot complete a lot, but I will at least touch upon the deterministic dynamic programming. Okay, any questions, guys? Please go ahead. We have good 20 minutes if you want to discuss anything. No question?
Sir, can you give that book name again, which you are following?
Sorry, can you repeat?
Sir, can you tell us which book to refer for this?
You can use Sheldon Ross book, or if you have purchased or have this Hiller and Lieberman book, that is also fine. Any
Okay,
of
sir.
OR book you will find these topics. Hiller and Lieberman, Taha, Ravindran. Of course, I am teaching mostly from, as I have mentioned last time, Introduction to Probability Theory, Ross book, Sheldon M. Ross book. You can use any of them.
Oh, okay, sir.
I will give you one more assignment. Let me see if I can, it will be graded or it will be just a practice assignment. I will let you know. You guys have submitted, all of you have submitted, or due date has not yet passed for the assignment 2?
Date is there, sir.
Oh, still that is there. So, okay, what I will do, I will give one more assignment, but it will be due just before your, whenever this exam happens. I don't know, offline or online, what more. So that you can practice also for your exam and you will submit that assignment. Is that fine?
Yes, sir.
Yes, sir.
Because if I give you
Sir,
assignment,
I have one.
yes,
Sir, in multi-dimension method, we will find lambda, no, sir?
in all
With
dimensions method we have to find lambda.
yes, sir. In multi-dimension method, we will find lambda with single dimension method. Sir, at that time, by hand, how can we get like to proper lambda? Means if we write code, that is okay. Then by hand, how many iterations we have to do? Like
Okay.
when we give you an example.
I will give you a relief. If in exam, if I give any question like that, you can find
Yes.
those lambda by just differentiating it.
Okay, sir.
Okay.
Okay, sir.
All of them will be in a proper quadratic or whatever form it will be, so that you can differentiate it and equate it to 0, and you can use that lambda.
Okay, sir. Okay.
Okay.
Okay, sir.
Or
Okay.
if I ask you, I can tell you for single dimensional line sets, use only 3 iterations or 2 iterations.
Okay, sir. Okay.
Okay.
Yeah, okay, sir. Thank you.
Any other questions, guys? If not,
In
yes.
the exam, whatever we have already covered, will that not be part of the syllabus, right, sir?
In the midterm, yeah, class test 1. Whatever have been asked in class test 1, that will not be part of your class test 2 syllabus. I believe this is what you're asking.
Yeah, yes, sir.